We have successfully completed our traffic light system. You have built a robust, modular application using professional object-oriented principles. In this lecture, we will recap what we achieved and discuss how you can take this project even further with some advanced improvements. By organizing our code into classes, we moved away from spaghetti code. Our main loop is now just a few lines long because the traffic light and potentiometer objects handle their own complexity. This is the hallmark of a professional embedded developer. Currently, our durations like red duration are hard-coded constants. A great improvement would be to add setter methods, similar to the setRate method we built for the LED blinker. This would allow you to change the traffic flow speed based on time of day or traffic density sensors. You could also integrate the push-button class we examined earlier. By adding an express check in your state machine, you could allow a pedestrian to request a light change, making the system reactive to real-world inputs. The real power of this approach is that each of these improvements can be added without rewriting the whole project. You just add a new method or a new class and plug it in. You've proven you can build a complete system. But how do you start your next big project from scratch? In the next lecture, 08.02, we will discuss the best practices and step-by-step workflow for building any Arduino project using OOP. See you there. Now that you have built a complete system, you might wonder, how do I apply these concepts to my own future projects? In this lecture, we will distill everything we've learned into a set of best practices. These are the gold standards for building professional-grade Arduino projects using object-oriented programming. When starting a new project, don't write code in the main loop immediately. Start by identifying your hardware components. For every physical part, a sensor, a motor, or a display, create a dedicated class. This ensures that hardware-specific details, like pin modes, are isolated from your application logic. The single most important rule in professional Arduino OOP is never use delay. Instead, use the heartbeat pattern. Every class that requires timing should have an update method. By calling these update methods inside the main loop, you allow your object to check the time and act independently without ever starting the CPU. Keep your variables private. Use getters and setters to interact with them. This prevents other parts of your code from changing a pin number or a critical timing variable by mistake. By protecting your data, you make your code bug resistant and much easier to debug when things go wrong. Remember, code is read much more often than it is written. Use descriptive names like is blinking instead of flag 1. This makes your project self-documenting. Always separate your classes into .h and .cpp files. This keeps your main sketch clean and makes your classes easily portable. You can simply copy these files into your next project and reuse them instantly. This copy-paste reliability is the true reward of good OOP design. Applying these best practices will transform you from a hobbyist into a software engineer. But where should you go from here? In the next lecture, 08.03, we will discuss the next steps in your learning journey and how to keep growing your skills. See you there. You have built a solid foundation in Arduino object-oriented programming. But learning doesn't stop here. In this lecture, we will explore the path forward discussing how you can scale your knowledge to build even more complex systems and move towards professional embedded software development. Your next step is to explore advanced C++ features. Look into templates to create generic classes that work with any data type, and learn about static members to manage data that is shared across all instances of a class. These tools will help you write even more efficient and reusable code. In this course, we touched on the state machine and observer patterns. There are many more design patterns used in the industry, such as the singleton pattern for hardware resources like serial ports, or the factory pattern for creating complex objects. Understanding these will help you solve architectural problems before you even write the first line of code. The ultimate test of a good class is if it can be used by someone else. Try packaging the LED, potentiometer, or push-button classes you built here into official Arduino libraries. Add a library Dart properties file and an examples folder. Sharing your work on GitHub is a great way to contribute to the community and build your professional portfolio. The OOP principles you've learned here, encapsulation, inheritance, and composition, apply to almost every modern programming language. Whether you move to ESP32, Raspberry Pi with Python, or even desktop application development with C# or Java, the logic remains the same. You are now a programmer, not just an Arduino user. The journey is far from over, but you have the tools to navigate it. Before we say goodbye, I have one last special treat for you. Join me in the next lecture, 08.04, a bonus lecture. See you there. Welcome to this bonus lecture. You have learned classes, inheritance, and composition. Now, I want to show you the crown jewel of object-oriented programming, holomorphism. We will see how to treat different objects, like a standard LED and a LED blinker, as if they were the same type, allowing us to write incredibly flexible code. Holomorphism means many shapes. In our case, it means we can treat a LED blinker as if it were a simple LED. This is possible because LED blinker inherits from LED. By using pointers to the base class, we can create a collection that holds different types of LED behaviors in one place. To make holomorphism work, we use the virtual keyword in our LED header file. This tells the compiler that when we call a method like turtle, it should check if a more specific version exists in a child class like LED blinker, and use that one instead. Inside LED blinker Dart-H, you update this line. And inside LED blinker Dart-CPP, you update this line. We can create an array of LED pointers. We point the first element to a standard LED and the second to a LED blinker. Even though they are different classes, we store them in the same LED array. When we loop through them and call turtle, the standard LED simply flips its state, while the LED blinker uses its overridden logic. This approach is extremely powerful. Imagine you have a system with 10 different types of outputs. With holomorphism, you can put them all in one list and update them with a single loop. Your main program doesn't need to know the details of each object. It just knows that they all know how to respond to the same commands. You have now seen the true scale of object-oriented programming. From simple variables to holomorphic arrays. you have the tools to build world-class Arduino software. This concludes our bonus session and our entire course. Thank you for being an amazing student. Go forth and create something incredible.
Happy coding!